Hey guys, welcome back to a beginner's series on restoring early tube black and white televisions. When we left off, we got a raster on the screen. Now, I thought it would be useful for me to give you some idea where I think we're heading. I have been, so far, making this up as we go. I have an overall plan in my mind of, obviously we're going to get this TV working, but as I've been getting feedback in the comments, I've been trying to focus on areas that I get a lot of questions about. So let's take a look at this list. Here's a little list of the next few topics I intend to cover. Since the last couple installments were all about doing a power-up and hopefully reforming the electrolytic capacitors, how about we actually check them next? Check the leakage current, check the capacitance, see if they are actually good, and if not, start talking about replacing them, which leads to the next topic. What kinds of parts are we going to be replacing? What are they made of? What modern parts can we use to replace them? Where can we get parts? And how are we physically going to install them? Times have changed, parts have changed. Not only the materials used, but the dimensions, the mounting. Let's go over that stuff. And then let's segue from that into test equipment basics. I've been getting questions about where do you hook test leads? How do you use test equipment? In the interest of getting this project done in a timely manner, I cannot include a tutorial on using an oscilloscope or how to use a multimeter. I appreciate that you'd like my thoughts or input on how to use them, and I may do that as a separate series of videos, but I will briefly go over some of this stuff. Also, I want to put out, I did not intend this series to be a beginner's guide to electronics. What I really intended this for was some of the particulars, oddities, differences in working on an early black and white tube TV. So I'm assuming you have some knowledge of how a voltmeter works and how to check if a resistor is good or not. But I will very briefly go over the equipment I'm going to be using and the very basics of how to set it up. After that, we're going to actually dive into working on this set. Alright, checking reformed capacitors. What am I talking about? Well, when we did our slow power up, we were hoping to revive the electrolytic caps. These guys in particular. These are the big filter caps for the higher B plus voltage and the lower B plus voltage. Let's start with this guy because it's very easy to see on the schematic. We're talking about this cap. It has two sections in it, C501A, C501B. And if you look really close, there are symbols next to it. That is a half moon, that is a triangle. There are symbols underneath the capacitor that correspond to those. They can be really hard to see. In this case, both sections are identical. They're both 40 microfarad caps. Let's flip the chassis up. Now be careful when you do this. We have these rather large tubes sticking out, and we have a cable on this end. If I flip it up this way, I'm going to mush that cable. If I flip it up this way, it may put pressure on one of the tubes. So what I suggest you do, we have these transformers here and they have a step design, is put a little something underneath this. Because if you tip it, it's going to rock back and kind of flop over because it's going to tend to do that. And that's bumping up into the 6Y6. So I'm going to put, let's see, how about a screwdriver handle underneath that transformer to prop it up a little. Beautiful, beautiful. So this is the cap. Let's get down in there closer. I'm talking about this. The can is common negative These caps can have 1, 2, 3, or 4 sections inside of them. The lower one, I believe, has 4 sections. The top one has 2, and they're both those 40 microfarad caps we're talking about. There are little tabs that come down, and they get twisted over to lock the cap to the chassis. That's why they call these twist lock capacitors. That's ground. Notice there's a blob of solder on some of them. That was to make a really, really solid connection. Whether not relying just on mechanical, with the twisting, they put blob of solder on it too, which makes it more difficult if you want to replace it, but not impossible. But that's our negative. And then the positive are the 2 sides. Now, these do go to other stuff. And the general rule is if you want to really accurately test something, it's got to be out of circuit. Usually, we have to take a look at what those actually go to. So this guy, one cap goes off to the other chassis. The only other connection to it, it goes through filter choke, goes to another cap, and then goes to the tube. So unfortunately, there are 2 paths for the leakage current. It can leak right through that cap to ground, but it could also go up through the other cap. So this cap could be fine. If the one above it is really leaky, we could be fooled because current can flow up that way. So unfortunately, we really do have to disconnect this to accurately test it. It's a drag, as it means we have to unsolder or cut wires. Now, I do intend to eventually replace these anyways, so I'm not that concerned about cutting a wire. And I'm not going to test all of these, I just want to give you an idea. So let's do the top one, because it just has a single wire going to it. It's going over the tube. If I had to replace this wire, it's no big deal. So I'm just going to cut it near where it enters that cap. Alright, so it's this brownish wire up here. We're just going to cut that. If after testing it was good, I could just strip this back and wrap it around that lug. Easy. Now, how are we going to test it? Well, there are a number of ways and instruments you can use to test a cap. Now, you may have a modern digital multimeter that has a capacitance mode or an ESR tester. Yeah, you can use those to check the capacitance, but I'm of the opinion to really accurately check these caps to see if they're healthy, these old school high voltage electrolytics, you need to test them at full rated voltage and check the leakage current. An ESR tester, equivalent series resistance, typically uses 100 kilohertz signal because that's what's used in modern switcher and power supplies. And a low ESR for those is very important. They have a lot of current going through them and it's switching very rapidly. This is a bit different. This will be 120 hertz for a full wave rectifier. And it's much higher voltage. I believe these are rated for 450 volts. So I pulled out an old school tester. I'm just trying to show you equipment that you could realistically obtain. And these seem to be relatively common. This is the solar version. There's also a Sprague Tello mic. And a number of other manufacturers. Paco made one. This is a bridge where you rotate this dial and watch the eye tube to check the capacitance value. And it has a neon bulb that flashes to indicate how much leakage there is. If it never flashes, you have very low or no leakage. If it's flashing very quickly or staying on, you have a lot of leakage. Yes, there are fancier testers that will show you the actual leakage current in milliamps, or of course, you can put a meter in series with this setup. But those testers tend to be, like I have a Pyramid CRA1, which will show you all that stuff. It took me years to find one, so I don't expect that you're going to be able to run out and buy one. These are fairly common, and it's fun, and I've restored this. I know it's accurate. To use it, there are several jacks, because this would measure capacitance and resistance. We want the left 2 jacks. The black is ground, Everything in this set has a grounded chassis, so we can clip this to the chassis anywhere. The other side goes to the positive on the cap. Keep this on 0 volts when you are doing this. Even so, don't touch the end of this. This can have several hundred volts on it. You don't want to get shocked. This mode switch right now is in paper mica. We want this to be an electrolytic, so we're going to throw that to the left. And you hear a click. This is for non-polarized caps. This is for polarized caps. Take a positive lead and clip it onto that cap lug that we isolated. Alright, let's do this in dim lighting so we can see the indicators more readily. We're going to put this all the way clockwise, and we're going to check for leakage before we bother to check for capacitance. Still have this knob on 0, and it goes 1, 2, 3, 4, 5. That's 100 volts, 200 volts, 300 volts, 400 volts, 500 volts, approximately. Check for leakage, rotate it. Notice it lit up and then went away. If I go back the other way, it flashes. That's good. You want to see that. What that's showing you is it's charging up to 100 volts. While it's charging up, yeah, there's current flowing into it. The reason it would flash is that it's charging up and then discharging, and charging up and discharging, because it's losing its charge internally as it leaks through the degraded insulating layers. So at 100 volts, we have no leakage. If there was a tiny amount, this might flash once every 10 seconds, every 15 seconds. We've got no flashing. Let's go 200. Excellent. 300. Lit up, no problem. That was charging up to the higher voltage level, and it's staying off. 400. Now it's struggling a little bit, but it did go out. Now I know this meter and I've tested it. It says 5. It's not quite 500 volts. It's more like 400, 400 and a quarter. So I'm going to go up all the way. If it really was 500, I wouldn't put 500 on a 400 volt cap. Now we're struggling. Which means this cap has not fully formed up to its full rated voltage. I'm going to get out a multimeter and we're going to check what that DC voltage actually is. You can also, by the way, form up caps using a device like this. Rather than me turning the set on, you could individually do the caps one by one. You could go start at 100, 200, and wait for that light to fade out. I don't think those lights, well, it may fade out eventually, but I also don't think we're even close to 450 on that cap. One, if it's leaky, it drags down the voltage. And two, this tester doesn't quite get up all the way there. So here's a multimeter. And I'm going to put this right on that lug. And what do we have? It's only 392. This cap is rated for 450. So we're struggling to get there. This is what I expected to see based on my past experience trying to do this a lot, is that often, yeah, sure, 200, 200, 300 volts, they're formed up. But when you get close to their full rated voltage, it's leaky. And this is exactly why I say, if you had a tester that only put 100 volts on it, you would think it was fine. No, not at its full rated voltage. This supply puts out close to 400 volts. And it's leaky. So what does that mean? It means this cap, over time, would get a little bit warmer inside. Well, first off, the fact that it's leaky at all is not, that's an indicator of health. If it's leaky, that means it's degrading inside. And it may very well likely continue to degrade, because what's going to happen is it'll start to get warm a little bit inside. That leakage current is going through the capacitor. It's acting like a resistor. There's current flowing through it. What happens when you have current flowing through something? It starts to get warm. That will accelerate the deterioration. It may take months, years, many hours of operation. All I'm saying is, in my mind, to call this fully restored, good to go for years of trouble-free use, I would not leave this in the set. If it's for your personal use, occasional demonstration, you want to learn some electronics, do some troubleshooting, like we've been doing, yes, the set does turn on. It does operate. Would I feel comfortable selling this to somebody, giving this to somebody as a gift, and saying it's fully restored, you'll have no worries? No, I would not. No, I would not. Alright, even though it's leaky, we can check for the capacitance. And by the way, a crude way to check for capacitance is after it's sitting here a while, it has charged up. If I start discharging it, notice it's lighting up. That's the charge bleeding off the cap. So it can hold a charge. Alright, capacitance, you go full counterclockwise, and then we rock the dial. And we look for, it's going to be kind of hard to see sometimes with the camera. Well, that's an eye tube. And there's a wedge on top. Actually, that eye tube looks better with the shop lights on. Alright, so we still have this fully clockwise. I changed the mode to be C1 in red. That's the electrolytic capacitor mode, and it's the outermost red ring. The idea is you rotate this knob now until, this is called an eye tube. On the top of it, you'll see that it will open and close. It'll be a dark wedge that will appear, and the size of that wedge will vary as I rotate this knob. So I'm going to start going counterclockwise, and it's starting to open there. I'm getting closer for you. There we go. 6E5 tube. Continuing to go counterclockwise. Well, now it's starting to close up. So that term rocking the dial means you rotate the knob back and forth, and try to get it right where it's maximum opening. This is a Wheatstone bridge circuit. When that's maximum open, that means the bridge is balanced. And then, to read the value, you look over at the dial. There's this early plastic strip here with a line down it. It's a little hard to see because it's gotten warped. But it's right around, let's see, there's a logarithmic scale, 70, 60, 50, 40. It's about 30 on that dial. So the capacitance is a little bit low, and it's a little bit leaky. So yes, I do intend to replace this eventually. We don't have to do it right now. We know the set is kind of working, as is the voltages. I've already checked them, are pretty much within specs, so we don't have to do it right now. Now there is something else too I shouldn't ignore, which is the percent power factor. If you rotate this, it also affects that pi wedge. So in addition to rocking this, you should also adjust the power factor for maximum deflection. The lower the power factor, the better. Looks like if I turn this up a little bit, it eye opens a little bit more. If I keep rotating it, it closes. So the power factor on this appears to be 3%, something like that. That's fine. I'm not going to get into what that means right now. Just know the lower the better. So for now, I'm going to reattach this cap. But in our minds, when we jot this down, that should be replaced. And by the way, there's two sections on here. If one is bad, since they're sort of rolled up together, the other one will likely be bad or will eventually go bad if one section is bad. So I'm not going to bother to disconnect it and test the other side. Alright, well, we have this power supply chassis flipped up. What else might we be concerned about? These guys, remember we talked about this earlier, these are paper capacitors inside plastic tubes, as is this one, and this one is just dipped in wax. These deteriorate, get leaky, but these are made out of paper and they are non-polarized, so the testing procedure is a little bit different. If you're not sure how to read these, it's a little hard to see, but that is brown. It looks gray, but that's black, and then yellow. Same as the resistor color code, 1, 0, and this is a multiplier. Yellow is 4 zeros. So 1 0 plus 4 more zeros is 100,000, and the value is in picofarad. It's 100,000 picofarads, also known as 100 nanofarads, also known as 0.1 microfarads. That's what we typically refer to them as, a 0.1 microfarad cap. The final stripe on here, yellow, that's the voltage rating. Yellow, 400 volt cap. Just as with the other part, to really accurately test it without having to look at the schematic and see what it's connected to, we can just snip off one end. And just like before, set our tester to 0. We're going to set our function switch, or type of cap switch, to paper mica. And we are going to clip our leads right across that cap. So there is one, and a little hard to see where the other end is going. To this lug on the terminal strip. Okay, let's see what the tester tells us. Okay, set our capacitor type to paper or mica. Get this clockwise. You check for leakage first. Go to 100. Seems to be okay. At 200. Uh-oh. It's flashing already. 300. It's flashing like crazy. Now here's where things get a little complicated. Does it matter? It seems the set kind of works okay. We get some sound. We kind of get something on the screen. All the caps can't be bad. Well, here's the thing is, I'd be willing to bet a sizable amount of money that every paper cap in this set is bad when tested at its fully rated value. If I go up to 400 volts, it's flashing like crazy. But here's the thing. When Admiral went to order parts for manufacturers to build this chassis, they'd look through and say, okay, what values do we need? We need half a dozen 0.1 caps. They want to buy them in volume. Capacitors back then came in ratings typically of 200, 400, 600. If one or two of them need 400 volts and the rest are okay at 200 or less, they would probably be inclined to just buy a truckload of 400 volt caps and be done with it. Likewise, there are a lot of 0.05 microfarad caps in this set. It's a very common value in TVs. There might be a dozen or more in this set. If one or more need ratings up to 400 volts, they'll just order a truckload of 400 volt caps rather than get 200 or 100 volt caps. So, if it's not leaky at 100, depending on where this is used, it might work fine. It might be a coupling cap between stages, and there's only a few volts AC and just a few volts DC on either end, and it could work for forever practically. And here's the thing. If you're running a repair shop, you're restoring this, you're going to sell it off to somebody else, do you want to go through and analyze every cap and see how is it used, how much voltage is on either end, and check them all one by one by one? That will take an enormous amount of time. So typically what you'll see restorers do is they shotgun the caps, meaning they just replace all the paper caps in one shot. I'm not going to go that far because I do want to demonstrate some troubleshooting and look at some waveforms before and after, that kind of thing. But generally this is what I do because my sets end up in the hands of folks who are not that well versed in electronics. Maybe they could change out a tube, that's about it. I want to make it as reliable as I reasonably can. I know these parts are invariably not up to spec, so I just go ahead and replace them. I do not test them all. But it is strictly not necessary. If you want to learn some troubleshooting, Learn how to use test equipment. By all means, test them all, analyze how they're used, and use your judgment in whether or not you have to replace them. I'll do a few more just to demonstrate that they are all going to be bad. Let's check out this guy. Brown, black, orange. They use grayish, by the way, because the body is black and they want it to stand out, so they use a dark gray rather than putting a black stripe on a black background. So we have brown, black, orange, 1, 0, 3 zeros, 10,000 picofarad, 10 nanofarads or 0.01 microfarad, and then that's blue, 600 volt cap. I've already clipped out one end. If you're going to do this, by the way, I strongly recommend you clip one end and then keep it nearby, so when you go to replace this, you know where it hooks back up. And of course, always take reference photos. Alright, let's check this guy out. Alrighty, let's start checking for leakage at 100 volts. So far, so good. 200. Dope. It's already leaky. If it's leaky at 200, certainly isn't going to get 600. And here, about 500, it's leaky like crazy. Now, I should point out that the newer your set is, the better chance you have of some or all the caps being good. And around about 58, they started using plastic film rather than paper and foil capacitors. Those are far more likely to be good. I recently posted some photos of a GE coaxial TV made in, I think, late 58. It had all plastic film caps, and it worked fairly well on those parts. Now, plastic will not last forever. No, it's not perfect either, but it lasts a lot longer. It doesn't have that same problem with the acid deteriorating the paper like the paper caps do. The earliest types would be brown, maroon kind of looking, and then you get the Sprague orange drops coming in around that as well. But this set is all paper. They are all leaky. I will be replacing all of them. Let's check one or two more for the heck of it. Let's do the other types, the one that's dipped in wax. Let's get this guy. Oh, I want to save that insulating bit of spaghetti there. So let's, some of these leads have some insulating material on them that's to prevent it from shorting into something else. It's nice to reuse that if you can. This one's printed, no stripes. It's 0.005, 600. 5,000 picofarad cap, or 0.005 microfarad, 600 volts. You know the drill by now. 100. Okay. 200. Don't. You may notice too, the smaller the value of the cap, the longer it takes to flash, because there's less surface area, less material to deteriorate. But yeah, it's bad. This is why you don't usually see me testing these caps, and I just replace them, because they're all bad. They're all bad. Let's try checking the value of this cap. Sometimes you can if they're very leaky. This eye tube just won't react properly, but let's give it a shot. Let's see, this is 5,000. I think we want to be in the smallest range, which would be C3. Now notice these, when you go to one extreme or the other, there's labels on here, open. If it's an open capacitor, the eye will open when you're all the way at this side. And this side has short on it. And when I'm at short, notice that eye is partially opened, meaning it's a partially shorted cap, meaning it's very leaky. So there's really not any point in testing it, but let's see if we get some indication of the value. What usually happens if it's leaky is you'll get a blurry pie wedge or indistinct. It'll change a little bit, but yeah, let's try the C2 range. I can't even, it's so bad I can't even check the value of it. I think that's enough for now. When we pick up, we're going to talk about replacing these. where can you get suitable parts, and how will we actually install them. There's more than one way to do it. We'll talk about several of them. Thanks for watching.